In this video we're going to talk about ModBus. ModBus is a PLC language which is a serial communication used to talk to PLCs and various devices. Peter Homan has a ModBus I/O board which is also out, which uses the same ModBus language. I'm going to be using his Mod I/O board for this particular demonstration, and although you cannot see his board, I'll show you how to set up ModBus and what the meanings of the ModBus variables are. To do so, I have ModBus configured on this system. You'll know ModBus is configured when under ports and pins, this selection, ModBus input-output support, is enabled. Once you've turned this on or turned it off, you have to exit the program and restart for it to take effect. If you have started the program with this in effect, then this setting under Configure, Set up ModBus Control, will be active, and you can bring up the ModBus test and configuration box. First of all, let's take a look at what's in here. Here we set the serial port number that we're going to talk to the ModBus device with. Here we have the baud rate, which is going to be the communication rate to the device. This baud rate is specific to the configuration of the ModBus control that you have or the PLC that you have. One of the first things to do with any ModBus or PLC device is to set these settings and then test your ModBus to see that if you have communications. By pressing the Test ModBus button, we bring up a special box which is just used to test your ModBus device. You can see here I'm set up for port 1 at 115 kilobaud. Slave address 1. If you have several ModBus devices, they may have different slave addresses. This is how you address them on the port to find which one you're going to talk to. At the current time, you could conceivably talk to, you could talk to 4 ModBus devices by changing the slave addresses here to correspond to the various ModBuses. But in reality, there's a limit of 2 due to issues of getting it too complex. If you had 4 running, you're going to be limiting yourself. I'll go into that in a moment, though. So here we have the slave address of Peter's board that I have hooked up, and it's slave number 1. Here we have a start parameter, and this is a start address. Now, Peter's board, starting at address 1150, has about 7 registers, that we can read. And we have to tell any ModBus device what we're reading. ModBuses have 4 general areas that we can read. They have input registers, holding registers, coil registers, and discrete input registers. In the case of devices that you're going to be reading from Peter's board, you would be reading the input registers. These are registers coming back into Mach3. So for example, on Peter's board, you'll have 8 input points that you can tie to, which are exactly like the pins on a printer port. His pins start at address 1150. And there are 7 addresses of information that we can read from his ModBus. So you can see I've set this to slave address 1, start register 1150 for 7 addresses. Each address in a ModBus is 16 bits. After opening the port, we can read the data, and you can see this is the data coming from Peter's board at the moment. The first word that's coming in is 0. This is a bit-packed word of his 8 bits of input data. You may not know what the data means in hex when it's coming from the board, and this is just a test to make sure the board is running. We're simply telling the ModBus device, and this doesn't have to be Peter's board, this could be a DL5 or a DL6 or any ModBus device. You can test it simply by setting its slave address, setting the start address that you're going to read from. Each ModBus device has a different start address for the data that you read from it. And each one will have a different number of registers that you read. Some people, for example, would only read one register from a ModBus device for the particular use they're going to put it to. As you can see, when I hit the read button, we read the 7 registers successfully, and that means we do have communications at 115 kilobaud with Peter's board. If I was to say that we only wanted 3 registers and we hit read, you can see that we're only reading the first 3 registers. Normally with Peter's board, however, Peter's board is a little special in terms of ModBuses because it's designed specifically to work with Mach3, so it sends in more information and in special ways than most boards would. You can see each time I press read that the data is changing. This is because there are timers built into Peter's board which are telling me the time between the last read of the MPG and the current read. There are also registers. As I turn my MPG wheel here, you can see the numbers are changing a great deal. This number here, you see the 24E2, which is in the 6th register. That's actually the count of MPG number 2. And if you'll watch, as I press it, staying at 24E2 until I rotate the MPG, and now the number starts to increment in one direction, and if I turn it backwards, it starts to decrement. So that's just to show you that the ModBus is working. Now you can also send data to a ModBus. We could, for example, here we type in the data that we're going to send to a ModBus device, and you can see I can just type a bunch of zeros or leave the random data. We're going to send to the holding registers starting at address 1040, which is the memory address of Peter's Mod.io board on its output registers. So we hit read, and you can see that we can still read from 1040, although it doesn't make any sense to do so because they are registers meant to write data to, and they're all set to 0 at the moment. If we hit write, we have no error listed, and we did write data to the board. You could set a bit pattern into these hex bytes and hit write, and on Peter's board inputs will become active immediately when you hit write because the terminal strip will then reflect what was in these boxes. So this is a good way to test a ModBus device. The status bar here will tell you if you're having a problem connecting to it or if you're trying to read an address that the ModBus device won't allow you to read. So when you're trying to get a ModBus device operating, to test your memory addresses and to test the way that you're controlling it, this is a great screen to use. For example, if you had a DL5 and it has an LED on bit 3, you could come into this device, put in a 4 hex, hit write, and the LED on the ModBus device would then light up. So the ModBus test dialog is very important to you when you're trying to set up an unknown ModBus device. For Peter's device, the unit comes pretty much pre-configured, and you only have to match the settings that I have. Here you can see that we have a section for inputs, and there are 2 types of inputs. There are inputs which are mapped to input pins 0 to 63. This is from the configure, ports and pins, input signals. When we talk inputs on the ModBus control board, this section here under inputs, we're talking about the input pins to the system. In other words, the Mod.io board is going to be sending input data into the program, and we can recognize it by using any signal on port 0, pins 0 to 63 as listed here. So for example, if I was going to use a Mod.io board input as input number 1, I would turn it on, set it to port 0, pin 0. Active low is used the exact same way as any other input from the printer port. So the only difference between a pin here and a pin on the printer port is that port 0 means ModBus. Port 1 or port 2 are printer ports. Another nice thing about Mod.ios is you can use up to 63 pin numbers for your inputs, and at the exact same time, outputs are analogous to this. If you wanted to send an enable signal out, you could turn it on, set it to port 0, pin 0 as well. So having a port 0, pin 0 in the outputs is allowed at the same time as an input of port 0, pin 0. And again, the pin numbers can be 0 to 63 as well as the outputs 0 to 63. And when you bring in memory from a ModBus control, here we're telling the ModBus that we're reading its input registers and we're mapping them to pins 0 to 63. Here's where we set an output. We have to tell the ModBus control whether we're outputting data from Mach3 to the holding registers or to coil registers. Some PLCs will use coil registers, some will use holding registers, and some won't care what you select here. The outputs are mapped to 0 to 63. This is to say that on Mach3, if you set an enable pin, for example, to port 0, pin 26, the data being transferred here is going to reflect those pins in the program. So these go out to the ModBus. There's a couple ways they can go out. On a standard PLC control, this is not Peter Homan's board, but on a standard DL5 or DL6, you put a start address of the memory block inside the PLC, and you would say how many registers. If you wanted to use all 63 pins, you would say transfer 63 registers. What is sent to the ModBus control are 63 16-bit words, which are either set to 0 for an output to be left off, or a 1 for an output to turn on. And that 1 or 0 configuration reverses if you uncheck the low active. So that's outputs to a ModBus and inputs from a ModBus for pin 0 to 63 of port 0. In addition to that, for PLCs like the DL5 and DL6, you can send in analog values. And we call these pins 64 to 127. Anything coming in on this second line from the ModBus gets sent to an array in memory, which are reflected by pins 64 to 127. We don't use those in the pins and port configuration. We only use these in macros. So for example, a DL5 may have an analog module on it, and you've hooked a potentiometer across it so you can control your feed rate override. You would tell it the address, starting address of the block of memory which contains the analog value of that potentiometer, and you would say that you want 1 register. This will transfer that register into analog array pin 64 or position 64. There are macro script calls to call the data into the program so that you can use that data in a macro pump or another script to automatically perform operations with it. Brian Barker, for example, has hooked up a potentiometer control his feed rate override. He simply sends it in from the ModBus into port pin 64, and he uses a macro pump to continuously monitor that value, and as it changes, he changes the feed rate override. Therefore, it's almost invisible to you as a user. You turn the pot and the feed rate override goes up and down accordingly. We'll have to explain macro pumps later. Obviously, at this point, if you've never heard of one, you're wondering what a macro pump is. It's simply a block of logic that runs repeatedly to tell the program to do something. Same thing with outputs. In outputs, we have an array in memory that we can access in scripts that are output pins 64 to 127. And again, these are 16-bit values, so they can be sent using the macro pump. They can be sent to a ModBus device and used to do things like control the spindle. For example, if you were to set a spindle speed in the program of 2300 RPM, the macro pump could look at that data, convert it into a 16-bit word, and send it out the ModBus port to control the spindle in real time, and you'd see no variations. So that's the basic section of ModBus. ModBus was added to the system to give you the capability of having an additional 64 outputs and 64 inputs. However, it is being used by some to control other things through the 64 to 127 analog value registers. These can best be addressed through the macro pump facility. The next video that you'll see appear is on the macro pump, so if you have questions on these, save them until then. So if you've just purchased a ModBus device and you're trying to set up a ModBus device, use your test ModBus control to test your memories to make sure that you do have communications, that you are getting the data that you wish. Generally speaking, the first 63 16-bit words that you transfer in to Mach3 become port 0, pins 0 to 63. A 1 in that 16-bit word will turn on that input, a 0 will turn it off. And again, the low active settings do affect that. Same thing with the outputs. If you tell Mach3 to send up to 63 registers to the ModBus at this address that you have set, this amount of registers will be transferred to the ModBus control. Each 16-bit word sent will represent a 1 or a 0 depending on the state of that particular output. Again, port 0, pins 0 to 63. For the 64 to 127 bits, those are used in a macro pump, and you'll see a video appear very shortly explaining how to use a macro pump and how to use those values. Again, these are a very advanced topic, these ones. The inputs and outputs are very easy to use. The only thing you need to know is your start address register and your start address register for both input and output. The update frequency here tells the system how often to send these packets to the Mod.io and to read from the Mod.io or any ModBus device. Typically, I set mine to 20 Hertz, so 20 times a second you will get data from the ModBus and send it to it. Down here is a small box which is used to support Peter Homan's Mod.io bus card. You can turn on 2 MPGs, and once I hit apply and I have a no error, I'm rehooked to Peter's card, and I can now configure it. Here we can set various options within the Homan card and send the configuration into the card to burn in different speeds, flash masks, pump delays, and various things that you'll find in the ModBus I/O manual. For general ModBus, you do not have to use this. You would simply uncheck it, and once you uncheck it, you can see all the numbers switched to numbers that are typical for a DL5 from Automation Direct. But again, for you to use all these values, you'll have to find the appropriate memory registers within your ModBus device. And when I switch it back, it becomes again pre-configured for Peter Homan's board. Here under Special Control, we have some controls that allow you to configure a bit differently. Normally, each 16-bit word sent to a ModBus control is a 1 or a 0 representing the pin number of the position of the register. In this case, however, you can check a box which says use each input word as 16 bits of bit-mapped input. Instead of sending 64 16-bit words, you could send one 16-bit word and have each of the bits within that word correspond to pins 0 to 16 in your device, in your ports and pins configuration for various input signals and output signals. You can also set one register. On the incoming registers, you could say for example, the 5th register becomes an OEM control code. Any number coming in that register would then automatically by Mach3 be run as if it were a button sending an OEM code. This is advanced programming of a PLC, and we'll leave that for a time when the documentation can probably be prepared. Brian Barker at Newfangled has done a great deal of work with DL5s and such, and will at some point explain exactly what you can do with his DL5 programs. So that's it for ModBus. It's a general explanation. You're probably somewhat confused. Until such time as the ModBus macros can be explained in a video to you, you probably won't find much use for the second line of each of these boxes. But the first one is pretty simple. It's just 16-bit words coming in, and each word represents a pin number 0 to 63. Same thing for the output. Here we have a timeout that you can set to tell the computer to give up on a message if it's taking any longer than 50 milliseconds to get a response. And this use RTS for transmit on an RS-485 is to increase the transmission frequency to PLCs that are run by RS-485 converters. And that's it for ModBus.